Can you move your sleeves?
All right, we are still on section 8.1, but today we are going to move on to
Section 8.2. Someone stole my pen?
we're going to move on to summation.
So that's 8.1
Hey, yeah.
4
8.1.
part 4.
Yeah.
Huh?
Summation.
Yes.
Oh yeah, it will be assignment 8.14, but I don't think I usually label your notes as 8.11 or 2 or. No, I don't.
Yep.
Yeah, you do.
I will pull up a video. And
Do it
we'll
right now.
see. Part one, part two.
Wait,
Let me see if I
summation.
wrote it down, because I wrote down everything.
Signal.
Ugh. Look at that 8.
She's graffiti.
I'm not the only one that
Here's what.
You're so funny too.
I was just thinking.
Oh, I thought we were
This
done.
right here is the symbol for summation. It is a Greek symbol, and the Greek symbol is called sigma. The Greek symbol is called sigma. This should be review from last year anyway. You guys remember that symbol, don't you? In fact, I think you had to use it in geometry in one of the sections too. Yeah.
You know the test we're doing right now is on that, right?
It is, but I don't think it's going to affect what you're doing.
Just, you know.
Yes. Okay. Yes.
How would you tell her that?
The sum
She's not like her son.
Trying to hate. That looks like some graffiti.
That's what I think.
Sean was just thinking alike today.
I know, bro.
Alright. The sum of the first n terms of a sequence is represented by this. I didn't leave myself enough room. You underneath this symbol, please put a. I'm sorry, you guys. Please put an I equals 1. That goes right underneath the sigma symbol. I equals 1. And go all the way up to the top of it and write an n. I equals 1 all the way to an n on the top. Of some rule. Where do you end? A sub 1 plus a sub 2 plus a sub 3 plus dot dot dot. Where do I end?
N.
How do you know you end at n?
Because it looks like it in there.
The top of this thing, right here, that tells you how many terms to add together. So if there's n terms, you have to add together the first n terms. So this last a is going to be an a sub n. So this symbol means that you take whatever rule you have and you add together the first however many terms it asks you to add together. So let's say that the n value is not an n, say it is a 5. You are going to add together the first term plus the second term plus the third term all the way out to the fifth term, okay? Yes, Marcus?
So, if the I was equal to like 3, would you start at the third term?
Yes, if the I was a 3, you would start with the third term and go to wherever it told you to end, okay? Yes?
When you say go to wherever it tells you to end, does that mean if the I was a 3 and the top number was a 5, would it go 5 more?
No.
Or just too far?
Okay, no. That is telling you where to stop. So it would say start at the third term, end at the fifth term. Do you understand what he just asked?
Mhm.
Okay, so whatever the bottom number is, that's where you start. Whatever the top number is, that's where you stop. The top number does not tell you how many terms to add together. The top number tells you to stop at that, for example, fifth term. Okay? All right. An example. Let's add together the first 7 terms. So I equals 1 all the way up to 7 of 4i. So when you add these together, the very first term that you are going to find is term 1, and then you're going to find term 2, and then you're going to find term 3, 4, and you're going to go all the way to the 7th term. So the very first term, a sub 1, is going to be equal to, this is your rule. So you're going to take 4 times I. Well, I for the first term is 1. So it's 4 times 1 is 4. The second term, a sub 2, is going to be equal to 4 times 2, which is what?
8.
Is 8. The third term, a sub 3, is going to be equal to 4 times 3, which is 12. Do I need to keep going? Where am I going to stop? You're going to stop all the way at the 7th term. So you're going to go all the way down to a sub 7 is equal to 4 times 7, which is 28. But the thing is you have to have all of them because your goal here is to add them all together. So what I'm going to do over here is write down that the sum of 4i is going to be 4 plus 8 plus 12 plus, and I have to figure out all of the terms all the way up to the 7th term, which I know is 28. But some of these things, you guys, do you have to do all of this stuff over here? I mean, I think you probably can figure out the pattern. How do you get from 4 to 8 to 12, etc.? You're adding 4. So you're adding 4, 8, 12. What's the next number going to be?
15.
16. Then a what?
20.
Then a 20. Then a what?
24.
Then a 24. And then you're going to end at the 28th term.
20, the 7th term. You said 28.
Did I say the 12? Stop at 28, which is the 7th term. Thank you. Add those together. What do you get? 112.
Yeah.
So the sum of the first 7 terms is going to be 112.
So would you put the equal sign next to the sigma? State where it equals all three?
The equals, what, this equal sign down here?
No, for the 112.
Oh, yeah.
Would you put that next to the sigma?
You would, I would
See
have.
you tell you
Put it right here.
I'm sorry.
Not really sure why.
I have a question.
Yes.
Will I always equal 1?
No, I will not always equal 1.
What happens when I equal something?
Well, let's say in this problem that I was equal to, let's say that this I value right here was equal to 3. If I was not 1, it was equal to 3. We would not include those two. We would start with the 12.
Oh.
The third term.
So, okay, so you're starting.
Yep, you're starting, yes. This number down here is your starting term number. Yep. All right, let's do, in fact, the next example that I have, I don't understand what is going on here. All right, this one actually, the next example I had planned is asking you to start at a different term. So we're not starting at the first term, we're starting at the third term this time. So find the value of this sequence, starting with the third term, ending with the 6th term, and we are going to use the rule 4 plus I squared. 4 plus I squared. So the very first term, a sub what is going to be a sub what?
3.
A sub 3 is going to be equal to 4 plus I, this I right here, which is 3, I squared. 4 plus 3 is 7. Squared is 49. So 49 is our very first term. Now this one might be a little bit harder to figure out a pattern to, so you may have to calculate each one individually. What is the 4th term? It's going to be 4 plus 4 squared. What is 4 plus 4 squared? It's going to be 64. All right, the 5th term. The 5th term is going to be 4 plus 5 squared. What is that? 81. What are these numbers, you guys? These are all perfect squares. 7 squared, 8 squared, 9 squared. What's the next one going to be?
10.
10 squared. sub 6 is going to be 4 plus 6 squared, which is 10 squared, which is 100. So when you find the sum of this, you are adding together 49 plus 64 plus 81 plus 100. I don't know what you get.
294.
294?
Yep.
In agreement, you guys?
Indeed.
294. Alright, what about this? Let's go from 0, the 0 term, all the way to the, let's do the 7th term, and the rule is 1 over n factorial. How many terms are we going to be adding together all together? 8 of them, because when you start at the 0 term and you go to the 7th term, that is one more than the 7 at the top. So the very first term, which is really the 0 term, is going to be 1 over 0 factorial. What is 0 factorial? 0 factorial is we defined that in your notes, I think, a couple days ago. 0 factorial is the same thing as 1. So 1 over 0 factorial is 1 over 1, which is 1. The first term, a sub 1, is going to be 1 over 1 factorial, which is 1 over 1. What is 1 over 1? 1. 2 factorial is 1 over, the second term is going to be 1 over 2 factorial. So you get 1 over, what is 2 factorial? 2 factorial means 1 times 2, which is 2. And I would leave it just like that. Leave it as a fraction. The third term is going to be 1 over 3 factorial. Technically, this is not the third term. This is actually the fourth term, but we call it a sub 3. It's going to be 1 over 6. The fourth term is 1 over 4 factorial. Well, you guys, 3 factorial is 6. So 4 factorial is going to be 3 factorial times 4,
24.
which is 24. So now we have 1 over 24. The fifth term is going to be 1 over 5 factorial, which is 1 over, take the 24 from the previous
120.
term and multiply it by 5. What's 24 times 5?
120.
120. The sixth term, a sub 6, is equal to 1 over 6 factorial,
720.
which is 1 over 120 times 6, which is 720. The seventh term is 1 over 7 factorial, which is 1 over, take the 720, the previous denominator, and multiply it by
5,000.
7. What do you get?
5,040.
5,040. Thank you.
54.
You said that like a big kid today, too.
80-40.
So now you need to add them all together. Now, this is the deal. It looks horrible to add together all these fractions, but the calculator knows the order of operations. You don't have to separate anything with
So
parentheses.
5,900.
You literally just add together 1 plus 1 plus 1 divide 2 plus 1 divide 6
On the bottom.
plus 1 divide 24, and so on. You can't just add together the denominators because you're adding together fractions that all have different denominators. The denominators don't do that. You have to find a common denominator, or you can allow the calculator to do it for you. So when you type it in, you are going to do 1 plus 1 plus 1 divide 2 plus 1 divide 6 plus 1 divide 24. No parentheses necessary. Go all the way out to 1 divided by 5,040. Get an answer. Change your answer back to a fraction.
Yep.
685 over 252. That's what I had to. 685. What is it again? 252. Okay.
Like go.
Now, what did you get before you tried to change it back to a fraction?
2 point something.
2.7 blah 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 blah. Does anybody remember what that means?
What means?
Oh,
2.7.
is that E?
It's E. Yeah, very nice. That's E. So what you just calculated here actually is E.
That's dope, bro. How'd you remember that?
Yeah,
Alright.
I remember stuff, but why would you remember that?
Two more examples. But we are not going to just find a sum this time. We are going to find what we call a partial sum. So find the fourth partial sum.
Ooh, I was just asking about that.
We can do it. Okay.
What's that?
What's a
Nothing.
partial sum?
A partial sum. A partial sum is a partial sum.
Thanks.
This sequence goes from 1 to infinity. It goes from 1 to 2 to 3 to 4 to 5. It keeps going on forever and ever and ever. But I am asking you to find what's called a partial sum. In this case, I want the fourth partial sum, which really just means you add what the first term is. So A, which is 6/10. We'll leave it like that for now. A sub 2 is equal to 6 divided by 10 to the second power, which is equal to 6 over 100. You with me here, you guys?
Yeah.
The third term is going to be 6 over 10 to the third power, which is 6 over 1,000. Still with me here?
Yeah.
No.
The next one should be over 10,000.
Yeah. So then the fourth term would be 6 over 10 to the power of 10 to the power of 4. So we have 6 over 10,000. Now our job is to add those four numbers together. So, again, when you add them together, let the calculator do it all for you. 6/10 plus 6 over 100 plus 6 over 1,000 plus 6 over 10,000.
Yeah, 2/3.
You get 2/3.
I didn't change it back to that
Yeah,
Six.
0.666 repeating. That's
That's
2/3.
2/3, yeah.
Why wouldn't it change it to a fraction?
It wouldn't let you change it to a fraction?
No, it doesn't. But it's still 2/3. Yeah, everything calculator. Maybe because there was only 4 6s, not like a bunch that has 7.
Okay, I gotta think about that.
Because you know
But
how
0.6 repeating is what your calculator's telling
Yeah,
you?
because you
0.6666666.
know how, like, when it's 2/3, it'd be like
Only 4 sixes.
yeah, it'd be like
Oh. Okay. Yes, you're right. 0.6, there's 4, there should be 4 of them, correct. Okay, because this, 6 divided by 10, that means 0.6. This means 0.06. This means 0.006. This means 0.0006. You with me there?
So for future reference, if it's like, will we ever have one like this again? Do you think?
I don't know.
Like where we have to find the partial sum
Yes,
with
you will
like
have to do
infinity though.
What did you just say?
Like that.
Yeah, you will. Yeah, but I'll ask you to find like the partial. What if I asked you to go all the way to infinity? What's going to happen to that number?
It's gonna get really small.
It's going to get really
Oh, maybe big.
well.
Long.
Right now, when you added together 4 of them, you ended up with 4 6s after it. So what if I asked you to keep
Oh,
going?
it's just gonna get long.
It's just going to get longer. It's going to become 0.6666666666666 infinitely far.
2/3.
Are we gonna have to find
Approximately.
infinity?
2/3. The sum is approaching 2/3.
It's like 1 over 0.99999.
All right, let's do this one.
98.
Last one.
So I got a question for you.
Yes.
So since it says infinity, we just gotta find like a couple.
Depends
on which.
Well, it
partial
said
sum.
specifically the directions said to find the
Oh.
fourth partial sum, okay?
Got it.
Yep, this one though, I'm asking you to find the sum
I need to listen to
of the series, and this time I want you to figure out what it is all the way out to infinity. So we're going from 1 to infinity, but the rule we are doing is going to be 6 over, same rule, 6 over 10 to the n. I didn't realize this was coming right up in the notes. We just talked about this, you guys. So the very first term is going to be 6 over 10 to the first power. The second term is going to be 6 over 10 squared. The third term was going to be 6 over 10 to the power of 3, etc. So 6 over 10 to the first power, as we just talked about, is 0.6. 6 over 10 squared is going to be 0.06. 6 over 10 cubed is going to be 0.006. And we could keep
So
going
how do
and
we-
going and going and going.
How do we write it?
How do we write?
How are we going to write it?
Like your final answer? Well, you were right a minute ago. We said it was going to be
Of course I'm right.
0.66666666, and it would keep going and going and going, which really means that
Oh,
we are.
so we'll just write 2/3.
Yep,
Okay.
we write 2/3, yeah. So the point is this: if I am asking you to find a very specific number of terms, then it goes 0.666. However many terms I'm asking you to add together, that's how many sixes you're going to have in your answer. But if we keep adding infinitely far, keep going and going and going and going and going, it's approaching the value of 2/3. Yes.
So, does that rule, 6 over 10 n equal, or is it the same as like
Okay, now
6?
hold on. You said 6 over 10 to the n power?
Yeah.
Yes,
Is
okay.
that the same as 6 parenthesis 1 over 10 and parenthesis to the power of n?
Yes.
That's too
You
much
just
work
asked
there,
this.
buddy.
You just asked this. Is 6 over 10 to the power of n really the same thing as 6 times 1/10 to the n power? Are those two things the same? That's what he's asking. Are they?
Yeah.
If you put 1/10 to the n power, that means you have to put both the numerator and the denominator equal to n. The n does not go to the 6. It only goes to the fraction. So we have 6 times 1 to the n power over 10 to the n power. What is 1 to the n power? 1 to the n power is 1. 10 to the n power is 10 to the n power. And what is 6 times 1 over 10 to the n power?
6 over 10.
6 over 10 to the
N power, yeah.
So that's what he was asking.
Same thing.
Yes.
Oh, goodbye.